So for numbers 11 and 12, we're supposed to figure out what the equation of the oblique asymptote would be. So instead of thinking of it really as an oblique asymptote, think of it as a diagonal end behavior model. So we have horizontal end behavior models, and we call those horizontal asymptotes. But if we have a diagonal end behavior model, we call it an oblique asymptote. So again, to find our end behavior model, we do the same thing that we have done when we try to find our horizontal asymptote. We take the most powerful term in the numerator, divide it by the most powerful term in the denominator, and we end up getting here, we get y equals x over 1, or y equals x. So our oblique asymptote would be y, end behavior model, y equals x. So that's it. You just reduce your fraction and you've got your equation for your oblique asymptote. What does that actually mean? Well, so it's important to understand what that actually means. If you graph y equals x, it's a diagonal line goes through the origin, but since it's an asymptote, we would draw it as a dashed line. There's our asymptote. We'll talk about how to graph those functions at a later time, but for right now, that's the equation of the oblique asymptote slash end behavior model. For number 12, this is an important one because we could see that we have the denominator's degree is greater than the numerator's degree. So we have x over x squared, which is 1 over x. Anytime you get the denominator of a fraction growing beyond bound and where the numerator is just staying constant, in other words, the denominator is going to get really, really big compared to the numerator. And so if you think about it as x grows, what's happening to the value of the fraction? 1/10, 1/100th, 1/1000th, 1 over 1 million. The values here are getting really, really close to 0. And so what we say for the horizontal asymptote is we would just say y equals 0. Anytime the denominator is getting really, really big, the values are getting closer and closer to 0. And so we have a horizontal asymptote. We don't have an oblique asymptote because the asymptote that we found is horizontal. The only time you have an oblique asymptote is if the denominator has a greater degree than the numerator. My bad. Let me say that again. The only time you have an oblique asymptote is when the numerator's degree is greater than the denominator's degree. That's it.